For this assignment, you're going to be looking at covalent bonding. So unlike ionic bonding, where ionic bonding takes an element from this side of the periodic table that wants to lose electrons and this side of the periodic table that wants to gain electrons, and those two just either give up or take, with covalent bonding, you're going to be looking at two elements from this side of the periodic table. And what they're going to do is they're going to be sharing electrons rather than just one giving it up and one taking it. So I'm going to go through and kind of give you an idea of what that's going to look like. So this is the worksheet you're going to be working on. So carbon is here, and the number of protons is going to be 6. Number of electrons is 6. Number of valence electrons is 1, 2, 3, 4. Number of electrons to fill the outer shell, it needs 4. Okay? That's how you're going to be doing these. So when you get down to here, you should have most of these filled up. We're going to look at hydrogen and hydrogen. So for the covalent bond, what I want you to start off with is I want you to start off with a Lewis structure. So we're going to have H and H. And to make it easier for this, I'm going to put the dot on this side because we know that hydrogen wants 2 in order to bond. And what's going to happen is it's going to end up bonding here. Now, when we draw that on paper, we're just going to go H, H. Okay, and you can also see it as H2. Tells us it's bonded. I'm going to go ahead and do one more. And we'll do oxygen and oxygen. Okay, so oxygen has, I'm going to start 1, 2, 3, 4, 5, 6, and oxygen has 1, 2, 3, 4, 5, 6. Okay, now these two want to bond. They each have 2 electrons that aren't paired that want to bond. So what we're going to do is we're going to draw a line here and a line here, and they're going to share those electrons within themselves. And what happens here is we end up with a double bond. So when we draw that a little easier, we're actually going to make it O, and then an equal sign, and then another O. And that's just representing the 2 bonds between the oxygen and the oxygen. Now, not all of them will be double bonds. You will want to watch for double bonds in number 5, but the rest of them should all be single bonds. But you might have more than one element, or sorry, more than one atom of a specific element in order to make it work. If you have any questions, please let me know.